Hi, everyone. Good morning, good afternoon, good evening. This is Rowan from Auto Department of Shanghai ViewThread Electronic Technology Corporation. ViewThread Electronic Technology is the owner, contributor, and maintainer of open source RT-Thread RTOS. Through several years of development, now ViewThread Electronic Technology has also released commercial edition RT-Thread Safety Auto OS, which passed functional safety certification. I focus on it for today's presentation. Here's my agenda. So wait a moment. I change it to presentation mode. Okay. I introduce it in 4 parts. First part is evolution of RT-Thread OS. Then a functional safety overview. Next, the RT-Thread Safety Auto OS introduction. Lastly, I show some Auto OS using scenarios. Let's go to the first part, evolution of RT-Thread OS. Let's look at RT-Thread evolution history. In 2006, RT-Thread began as an open source RTOS, and it had initial release 0.1.0. Then in 2011, it had first complete RTOS feature release 1.0.1. In the same year, the building tool Sconce was also released. Then in 2017, release 3.0, version 3.0 was released. A second variant Naro was also released for resource-constrained microcontrollers. It only needs a minimum of 3 KB flash memory and 1.2 KB RAM. During 2018 to 2020, the version 4.0 was released, which can support SMP. We also released RT-Thread Studio IDE and the long-term support version for 3.1.x. Starting from 2020, there will be 2 paths for RT-Thread development. One part is still for commercial edition development. During this period, we release several community editions. For example, 5.1.0, this is the latest release we just released a month ago. The another path is for commercial edition development. During this period, we release a commercial variant, Safety Auto OS, with ISO 26232 ISO-D functional safety certification. In these slides, I show some highlights about Safety Auto OS. Safety Auto OS can reuse community-based ecosystem. Safety Auto OS is not built from scratch. It's based on RT-Thread 4.1.0. It is highly configurable, durable for flexibility. It can easy to integrate critical third-party components. Secondly, it has functional safety certification. We built Safety Auto OS with safety and security in mind. It is certified for ISO-D functional safety. The smooth path to product safety certification. Safety Auto OS is also full-stack Auto OS. It can support lightweight AutoSAR CP stack. It has layered architecture. and many tailored modules. We also release integrated configuration tools, Clarence Studio, together with AutoOS. Safety AutoOS, we can provide professional tech support. There's local support and technical guide for it. We also made some custom product performance optimization and reduce time to market. Let's take a look at Artistrat partners. We have partners from automotive domain, industry automation, power automation, and rail transit domains. Artistrat Commercial Edition is not only used in automotive domains, but also used in industry automation, power automation, and rail transition domains, which have some functional safety requirements. In automotive sectors, we have partners from autonomous driving technology companies such as Pony AI or WayRide. We also have partners from automotive OEMs such as Jidu, Liu, Chang'an car makers. We have partners from solution providers such as DCSV Automotive. Of course, we also have partners from chip providers such as Infineon, TI, and NSP. And let's go to the functional safety overview. One President Dogger from Renesas in previous presentation has mentioned some about the functional safety. Let's see more about it. In these slides, I show some functional safety requirement. In this diagram, we can see different products have different safety levels. Consumer electronics, industrial-grade products, automotive-grade products exhibit significant differences in functional safety requirements. These differences are primarily reflected in functional safety standards, application environments, safety integrity levels, testing, and verification methods. Frankly, automotive-grade products have rigid requirements for functional safety, followed by industry-grade products, while consumer electronics are relatively more lenient. In these slides, I show some concept of functional safety. This diagram actually shows a traditional three-level functional safety modules. The first level is called the functional level, which implements the functional control functions, system control functions, and the control system reactions if first detected. Level 1 also includes component monitoring and input-output variance diagnostics. The second level is called functional monitoring. It can detect defective process of level 1 functional software, for example, by monitoring the calculated control output. Level 3 is called controller monitoring. It includes two parts. Part 1 is integrated safety mechanism in a microcontroller itself. For example, it can support built-in hardware self-test, program follow, check, etc. Part 2 is called safety level, system level safety mechanism. It implemented by independent modules, SBC, ASIC, or another microcontroller. In these slides, I show some functional safety mechanisms. Actually, there are 4 typical mechanisms defined in AUTOSAR CP specifications. The first is a memory partitioning. Memory partitioning is a technique used to logically separate different areas of memory used by various software components in a system. It can be implemented through specific hardware, such as memory protection unit. The second one is timing monitoring. Time monitoring involved supervision of timing behaviors of software and hardware components to ensure that they operate within predefined time constraints. Time monitoring techniques can include watchdog timers or specialized hardware timers. The third one is logical supervision. Logical supervision refers to the process of overseeing the logical operations and decision-making process in a system. It often implemented through redundant system or software that can cross-check each other's output to ensure correctness. The last one is end-to-end protection. End-to-end protection refers to comprehensive security approach that can ensure data integrity and confidentiality from source to a destination. It can involve encryption, authentication, integrity check, and access control procedures. The diagram on the right shows the memory partitioning architecture defined in AUTOSAR CP specification. Here we can see the AUTOSAR OS provides 2 types of OS applications. Trusted applications run in kernel or supervisor mode with full access to OS services and system resources. While non-trusted OS applications run in user mode with restricted access. The resource among different non-trusted applications are also isolated with restricted access. Here we can see the communication between the non-trusted applications and trusted applications is facilitated through well-defined protected interface. Here is RTE, AUTOSAR runtime environment. It can provide well-protected APIs to communicate between the OS applications. In these slides, I will show product functional safety development. We can see in this diagram, product safety development involves 2 parts, technique part and process part. For process-related aspects, we can see it include process definition and process deployment. For technical aspect part, it includes technical safety requirements, system architecture design, and product development at software level. In short, both process-related aspect and technical aspect contribute to product functional safety. Let's go to the part 3. In this slide, I show the Safety Auto OS architecture. We can see the safety kernel is located between the hardware adaptive layer and the middleware layer. It consists of several modules. All the modules marked with yellow are ISO D certificated. The debug and trace module is just in a QM level. Let's take a look at some modules' functionality. For memory protection module, it can provide privileged, non-privileged access and partitioning mechanism. For memory management module, it can provide memory heap mechanism and memory pool management. For task management module, it provides priority preemptive scheduling and time-slice round-robin scheduling mechanism. For the failure process module, it can provide force monitoring, handling, and notification mechanism. We support the mainstream chip architectures, include ARM Cortex M, Tricore, and ARC, etc. Later, we will also support RISC-V Cortex. We can also support many mainstream cross compilers in the automotive field, such as Tasking, Hightech, and Greenhill. In these slides, we show the OS step. We can provide the full set of DAP for our customers. DAP means Design Assurance Pack. It contains all the design and verification artifacts required to support ISO 26262 ISO D certification. It can easily be integrated to customers' developer environment, and it can reduce developer costs and improve time to market. It can also provide smooth paths to certify the whole product if necessary. The diagram on the right shows the certificate we just got. In these slides, we show Safety Auto OS code structure and build environment. Actually, we keep same code category as community edition. We can see here, it includes BSP folder. BSP folder include board support packages based on porting of variant development boards. It also includes a package folder. Package folder include middleware-related packages. It can be either closed-sourced or open-sourced. Next is a documentation folder. It contains some related documents such as building guide, coding style, etc. The next one is Artist-Red folder. Artist-Red folder is the most important folder, include the core kernel part, libCPU, and the components part. The next one is tools, includes some scripts for Artist-Red command build tools. It also includes Canary Suite configuration tools. Then we can see the building tools. We use the same building tools as community edition, such as env tools and sconce command. We can also support queue, IR tasking, set IDEs. In these slides, I show some differences between commercial edition and community editions. Commercial editions specially designed for high safety fields such as automotive and industrial automation, providing customers with comprehensive and reliable software foundation platform. While Community Edition is designed for embedded systems with little function safety support, particularly well suited for IoT systems. Commercial Editions is used in analyzing mode, is supported by professional technicians, while Community Edition is open source, supported by community and parts of professionals. Commercial Edition is fully performance optimized for specific chip architectures. Community Edition is just a common version for community with partial performance optimization. Commercial Edition support customized process APIs. However, Community Edition can support full process APIs. Commercial Edition only support partial reliable packages. Community Edition has a rich ecosystem of software packages. Commercial Edition not only support some chip architectures, many focus on the automotive-grade chips. Community Edition can support a variety of hardware architectures. Most are IC-related or industry-grade chips. Let's go to the next part. In this part, I show some usage scenarios about SwiftOS. Use case 1 is AutoMCU total solution. In this diagram, we can see accurate safety kernel with AutoSAR's API support, coupled with a white-knight AUTOSAR CP middleware, forms a complete AutoSAR solution, automotive-grade MCUs, helping automotive companies to reduce costs and improve efficiency. On left is a solution being developed by RT-Thread and one OEM based on Cortex M4 MCU platform. In addition to support basic COM, PDR, CAN, NIN modules, it can also support J1939 service-related modules, which can be used commercial vehicles and heavy machinery equipment sectors. This is use case 1. Then show another use case. This T-box MCU solution. T-box refer to the pneumatics box. It's a device widely used in automotive industry. Provides various information and communication services. It combines the function of telemetry and informatics. The diagram on left illustrates the T-box solutions, which is co-developed by RT-Thread and Taiwan solution provider. On left the diagram, we can see RT-Thread SwiftOS runs on the MCU platform in T-box, providing safety features, adapting to a custom AutoSAR middleware and application software components. It not only communicates with vehicle body controllers via the CAN bus, but also enable two-way communication between the vehicle and the central server by interacting with a COM module through the UART, USB and GPIO interfaces. I'll show another use case. This ADAS MCU solution. ADAS means Advanced Driver Assistance System. Smart driving solution provide integrated artist-thread safety auto kernel and infinite multi-core MCUs enable vehicle control through CAN and CAN-FD implement certain safety monitoring functions. Artist-thread safety auto is running on NOC safety MCUs. It's not only implement the safety functions in MCU itself, also provides safety monitoring functions for the ADAS SoC here. Artist-thread safety auto OS can be customized to support process APIs. I can also integrate the lightweight AutoSAR CP solution, meeting both traditional process programming and model development in line with AutoSAR specifications. You can provide TCP/IP, Ethernet, and application protocols, and also provide Ethernet to CAN and CAN-FD message processing functions, and provide vehicle diagnostic support. Okay. That's the last slide about our company profile. Our company headquarters is located in Shanghai, with branches in Chengdu, Wuhan, and Shenzhen. If you have any business cooperation requirement, please visit our company official website. Okay, that's the end of my presentation. Thanks.
Well, thank you so much. That was very interesting indeed. I didn't get my first car till I was 30 years old, and I didn't even have electric windows. So thinking about today's automobiles with, you know, real-time operating systems and all these computers and everything, it's sort of mind-blowing. I'm too young for all this excitement. So thanks again, Yu. That was wonderful.
Yeah. Yes.